Lesson 83, Factoring Special Products. What we're going to worry about most in this lesson is not necessarily memorizing the form for special products, but again, practicing being able to factor trinomials. There are a couple things that I'm going to tell you about perfect square trinomials so that you know what they are. If it's a perfect square trinomial, whenever you factor it, it will be the same as taking that quantity times itself. It'll be the exact same thing inside of parentheses. So on this one, when I factor it, it would be the quantity of a plus b times the quantity of a plus b, which is the same as saying a plus b squared. So that's a perfect square trinomial. Same thing here. This one would be the same as saying a minus b times a minus b, or the quantity of a minus b squared. So it says determine whether each polynomial is a perfect square trinomial. If it is, factor the trinomial. We're going to factor them regardless. So I'm going to, on a, whenever I factor this one, I have that I'm trying to multiply to get 49, but I need to add to get 14. So things that multiply to get 49 are 1 and 49, 7 and 7. So obviously 7 and 7 will get me 14. These are both positives. So I have x, which I'm going to split. I said they both have to be positive. And then 7 and 7. So this would be a perfect square trinomial. It would be the same as saying x plus 7 squared, because x plus 7 times x plus 7. Okay, on this one, for me to get a negative here, I have to have a positive and negative. So whenever I split these, I would have x times x, and then I have to have a positive times a negative to get a negative. Well, if my signs are different, then there's no way that it's a perfect square. So I'm not perfect square trinomial. So done with that one. On C, before I can factor, we should always see if we can factor anything out of all of these. If I don't have that coefficient of 1, I don't have a coefficient of 1 here, and there's nothing that I can factor out of all three, so I have to take A times the absolute value of C. So that is 16 times 9. Okay, so in my calculator, punch in 16 times 9, which gets me 144. There are lots of things that get me 144. 1 and 144. If I do 2 and 72, that'd be 3 and 48. 4 and 36. 6 and 24. So then my last one should be 12 and 12, I believe. So now, of those, for me to get a negative 24 here, okay, for me to get this 24, I have to say which of these is going to get me a 24. Obviously, that's going to be 12 and 12. So I'm going to write 16x squared minus 12x plus 9. Okay, I did this because this is the same thing as going right back from here to the original. Okay, so then I'm going to split the first two and the last two. I'm going to group them, put a plus between because I'm not multiplying. Here I can factor out 4x, which leaves me with 4x minus 3, plus here I can factor out a negative 3, which leaves me with 4x minus 3. So then if I factor out of these two, I can take 4x minus 3 out of both, which leaves me with 4x minus 3 in the other one. So this one would be a perfect square trinomial, and the quantity of 4x minus 3. Okay, on this one it says Frida throws a rock into the center of a lake. After a second, the area inside the ripple is pi r squared square inches. After t seconds, the area inside the ripple is pi r squared plus 16 pi r plus 64 pi square inches. How many inches has the radius increased? So all I have to do is take the factor this. So I have pi r squared plus 16 pi r plus 64 pi. Before I can start, I need to factor pi out of each of them, which leaves me with r squared plus 16r plus 64. Okay, now from here, I want you to finish this problem. Factor it, and it wants to know by how many inches it increased. So whatever I'm adding to r is going to be the increase. So finish by factoring this. The difference of two squares, this one you do need to know because it's only going to give us two terms, and it has to be a difference, which means we're subtracting, and the other two have to be perfect squares for us to be able to do the difference of two squares. And that is that we take the square root of the first one and we put it in the front of both, and we have plus and minus, and then the square root of the second one, and we put it at the end. So, for example, it says determine whether the binomial is a difference of two squares. If so, factor. So here, difference that's being subtracted is 100 a perfect square. Yes, x squared is a perfect square, and so is 5. So I'm going to set up my two sets of parentheses. 100 squared, or the square root of 100 is 10. The square root of x squared is x. I said we were going to put plus and minus. The square root of 25 is 5. That's my final answer. On the next one, is it a difference? Yes. Is it a perfect square? 2 is not a perfect square, so I cannot factor this one. Okay, so that one, no go. Unless I factor out, let's see if I can factor 2 out first. I get x to the 6th, and 288 divided by 2 gives me 144. Oh, look, you have to be careful. Sometimes we have to factor out our greatest common factor first. Now I do have a difference of two squares. So I have 2. The square root of x to the 6th would be x to the 3rd, because x to the 3rd times x to the 3rd gives me x to the 6th. I'm going to do plus and minus. The square root of 144 is 12. Final answer. On C, do I have a difference? No, so I cannot do this one. No go. On D, I don't have a difference the way it's written, but I need to write it in standard form, which would be x to the 10th minus 36. Now I do have a difference, and I have two squares. So I'm going to write my parentheses. The square root of x to the 10th is x to the 5th. I have plus and I have minus. The square root of 36 is 6. I have a final answer. Okay, so it says a large square has an area of 121 square inches. A small square has a side length of y inches. What is the polynomial representing the difference in the areas of the squares in factored form? So I have a large square that I know has an area of 121. I have a small square that has a side length of y. The difference in the areas. So I know what this area is. This area is 121. Minus the area of this square, I would take y times y, because I'm taking side times side, so I have y squared. It wants it in factored form. I want you to finish it on your own paper. I hope that you've taken good notes, and I will see you in class tomorrow. Have a good night.